Hello and welcome to another episode of Dave Does Calculus at Home. Today is the first part of a new section. We're going to look at parametric equations, which are super fun, very interesting. I'm very excited about this topic. One of my favorites. It's a big one though, so it's probably going to be a 3 or 4-parter. So strap yourselves in, make yourself comfortable, and let's talk about some parametric equations. The standard kind of functions that we are used to seeing look kind of like this. Y equals 3x squared minus 7. This is an explicit function. This is y as an explicit function of x. We can graph it if we want. It probably looks like this. It's down here at minus 7. It's parabola in the meantime. And when we're graphing functions that look like this, we have this rule that says any given input for x has to result in exactly one output for y. You can't double up on your outputs. And graphically, that looks like the vertical line test. So this is what we're all used to, which means it is time for me to take that away from you and start talking about stuff that you are not used to. We're going to make it weird. Consider a cat toy under my feet. Consider a kind of function where instead of x and y being directly related to each other, x and y are both separate functions of a third input variable called t. Or, I guess you can call it whatever you want. Usually it's called t. So instead of something like this, we might see something like y equals 4t minus 1 and x equals 2t squared. This is a parametric function. T is the input variable. You can pick numbers for t, and when you pick numbers for t, it will give you x and y values. And then you can use those x and y values as coordinate pairs to graph points on an axis, and then you can connect the dots and you get yourself a function. One of the weird things about this is that t does not get graphed. T is your independent variable, it's your input variable, but it's not one of your axes. It will determine sort of like where you are on a graph, but it's not, it'll determine like what part of a shape you're on once you sort of know what the shape of this is. But it's not actually like something that goes on an axis. You still just have your regular x-axis and your y-axis. There's no t-axis. So let's take a look at this thing, see if we can figure out what shape this thing is going to make when we graph it. And as always, you're going to approach the idea of graphing an unfamiliar function using a table of values. This table of values is going to probably look a little different from what you're used to though. Here's how I'm going to set it up. I'm going to have a row for t values, I'm going to have a row for x values, and I'm going to have a row for y values. Instead of choosing a collection of x values that I think will fit nicely into this function, x is not my independent variable. It's not the input anymore. T is the input. So I'm going to choose a collection of t values that I think will fit nicely into this function. I think I can probably get away with 7 of these. -3, -2, -1, 0, 1, 2, 3. It's going to be a tight squeeze at the end there. That's alright. Okay. If these are my t values, then I need some x values. X is going to be twice these t values squared. So this would be an 18, an 8, a 2, a 0, a 2, an 8, and an 18. Now I need some y values. Y values are going to look like this number multiplied by 4 and subtracted 1. So negative 13 for the first one, negative 9, negative 5, negative 1, 3, 7, and I really need more space over here. Sorry, I wish I had a bigger whiteboard. Let's slide this over a little bit. Y equals 4t minus 1, x equals 2t squared. Now I can spread this out. Make it not so cramped. 1, 2, 3. What did we say here? 2, 8, 18. And the last one's going to be, what, 3? Yes. 4 times 1 minus 1 is 3. 4 times this minus 1 will give me 7. And 12 minus 1 gives me 11. So, this is a generated table. It includes some t values that I sort of picked arbitrarily. And then it includes some x values and some y values that I can use to, I can calculate these based on the inputs of t values. And then I can use these guys to put some points on axes and sketch myself a graph. So I'm going to do that. Looks like for x values, I'm going to stay pretty positive. Y values look like they need to switch between negative 13 and 11. So, let's go 5s here. 5, 10, 15, negative 5, negative 10, negative 15 on the y-axis. That should cover those guys. And then, so on the y-axis. On the x-axis, I need to get out to 20-ish. So we'll call this 20. We'll put 10 right in the middle. We'll do 5 there and 15 right here. Okay. So I have some axes. They're labeled. I gotta put some points on here. And I'm going to put these points on here in this order. I could do it in any order, but I'm going to do it in this order, and I'll explain why in a little bit. So I'm going to start with the x is 18, y is negative 13. That's going to be down here. This is sort of the first point. And then x is 8 and y is negative 9. That'll be here-ish. X is 2. Y is negative 5. That'll be right here. 0, negative 1 is here. 2 on the x-axis. 3 on the y-axis is up here. Oh, this was... Yeah, this is right. 2 on the x, 3 on the y. That looks good. 8 on the x we said was here. 7 on the y is probably right here. And then 18 on the x and 11 on the y. It'll be out here. What was this? That's a little tall. Move this up a little bit. Okay. So, you can kind of already see the shape of this from the points that we've chosen. It's going to come up like this, turn around, and head out this way. There's a couple things about this graph that I want to talk about. The first thing I want to talk about is probably the obvious thing that may or may not be bothering you. This function fails the vertical line test. You put a vertical line through it, crosses it twice. How can this be a function? This is a function because when we defined function, whatever, years ago, whenever I last had you for pre-calculus class, we defined function, we said that each input has exactly one output. If your x values are your inputs, that's what gives you the vertical line test. Each input is an x value, and that has to only hit this graph once. In this graph, x values are not our inputs. Our inputs are t values. They're not graphed, so there's no vertical line test for parametric functions. Each input gives me an output that is this point. So like the input t equals -2 gives me an output value of 8, -9. The output is your entire point. This is your input. And so we still have this relationship. Each input is giving me exactly one output. That output is a point. There's only one point. The input t equals -2 can't give me any other point. I don't have options here. It's just this point. Single point by itself. So we're still good on the function clause. The other thing I want to mention about this graph that is unusual is that this graph is oriented. And what I mean by that is it travels this path in a direction, which is why I started with the t equals -3 points. As t increases, the function moves in this direction, and then it turns around here, and as t continues to increase, it goes in this direction. If the orientation of a graph is an important part of a problem or a model or an example that you're doing, then this graph has to count as a different graph than something that has the same shape but a different orientation. If you put a negative sign on these y values, then you'd probably be starting up top and going down. It would be a really easy way to switch the orientation on this graph. And you would get the same shape on a piece of paper, but it would be a slightly different function with a slightly different graph, because sometimes the orientation matters. Sometimes it'll matter if you're going vaguely upward or vaguely downward. So that's something we need to be aware of as we move through the problems in this section. The other thing that we're going to have to do while working with parametric functions is we're going to have to figure out how to represent them using a regular function. So for this particular example, we're going to find that we kind of can't turn this into like a regular y equals some function of x thing, again, because if x is our input, this is going to fail the vertical line test. So I'm going to cut the video here. I'm going to start the next one with another example that we can sketch a graph of and then transform into a regular function. Stay tuned.